Module 4, Objective 5, describe the sliding filament theory and be able to explain in detail what is happening in the sarcomere throughout this mechanism. The sliding filament theory is a theory that has been devised to account for all the processes and changes that occur during contraction. We can visualize and see that the H and I bands narrow during contraction, that the zones of overlap widen, that the Z lines move closer together, and that the width of the A band remains constant. From those observations, it's been hypothesized that the thin filaments must slide towards the center of the sarcomere. I'm going to demonstrate through some really fancy graphics here that process. So we see here a muscle in a relaxed state. Here's a muscle in a contracted state. And if you take the time to look at that bulleted point that we just presented, you can see what's happening. So the A bands are going to remain the same between the two. Again, the A bands sort of denote the thick filament where the myosin is, and that does not change. But there are some changes. The H band is going to become more narrow. The Z lines are going to move, closer together, and we can see that happening here. And the only possible explanation that has been produced is that there is some type of interaction between the actin and myosin molecules in which the actin slides upon the myosin. They slide towards the myosin, towards the middle of this sarcomere, and that's going to cause a shortening in the sarcomere. Muscle contraction, the process of contraction, requires neural stimulation, and a neural stimulation of the sarcolemma. And from that nervous input, from the signal from the nervous system, it's going to cause what's called the excitation contraction coupling. Let me say that again. Excitation contraction coupling. And this involves the cisternae, the terminal cisternae of the sarcoplasmic reticulum, and the release of calcium. Calcium is responsible for the interaction between the myosin and the actin filaments. This is a very highly active process. It's going to consume a lot of ATP. And as the sarcomeres shorten, they're going to pull on the tendons attached to the ends of the muscles, and that is going to produce this concept of tension.